All right, review for the final part 1. So it's going to cover week 1 and week 2. So math, chemistry, physical science, and this class was for RT. All right, you guys recall your decimal places? All right, so make sure you guys recall that on this side of the decimal place, it is ending with an S, and on this side of the decimal place, it ends with THS, right? So always look at that, and sometimes I'll use decimals, sometimes I'll use to the nearest whatever. It might be a fraction, might be a decimal. Just know they all mean the same thing, and you guys know how to convert from fractions, decimal, and percentages. All right, rounding. Find the decimal place in question. Look to the right. If the number to the right is 0 to 4, you round down. That means the number in question stays the same. Everything else becomes a 0 after it. If it is 5 through 9, you round up. That means the number in question increased by 1. Everything after that becomes a 0. All right, so let's do some rounding. I punched in some numbers. Round to the nearest tens, everyone. Let me know what you get.
4, 3, 9, 7, 2.
0, right? 0. So tens is in question. You look to the right, it's a 0. So the 2 is going to stay the same. Everything else after it becomes a 0. So you just round down. All right, to the nearest tenths. Which number is in the tenths? The 6. So we look to the right, and it's a 5. Someone already said it. It goes up to, so you add 1 to the 6, it goes up to 7. So if it's a 5 or higher, you round up. All right, nearest 0.001. What number is in the 0.001 decimal place?
1.
So you look to the right. It's not there, but we all know it's a 0. So since it is 0 through 4, we round down, right? So it just stays the same. No new information. Bam. What number's in the hundreds? 7. So you look to the right. It's a 2, so you round up or down? Round down, right? It's a 2. 0 through 4, you round down. So always look to the right. That determines if the number in question stays the same or increases by 1. All right, so that was rounding. Let's go to scientific notation. So instead of writing a bunch of zeros for large numbers and a bunch of zeros for very small numbers, 10 to an exponent. So you got to understand what the exponent means. Okay? So scientific notation, you're going to change your number between 1 and 10, has to be a value between 1 and 10, multiplied by a power of 10, 10 to an exponent. So here we got 250, that's 2.5, that's the number that's between 1 and 10, times 10 squared. So what is 10 squared? 10 squared equals 10 times 10, right? So that equals, so we got 2.5 times 100, that equals 250. So it's a relatively small number, just so we can see the pattern. Right? So if you move decimal 2 places, that side, then you know it's going to be 10 to the 2. That's your exponent. So here we got 0.0015, and we're going to move the decimal point 3 space that way to get to a number between 1 and 10. So that's going to be a negative exponent. So 10 to the negative 3 equals 0.001. 1/1000.
Can I ask a question? So in general, based on our answers we put in, is our problem or is that rounding?
A lot of it is from your quizzes. Yeah. But the homework, you guys seem to be a lot better on the homework. Yeah. I think the quizzes, they're more specific. All right, so what's your number between 1 and 10? 9.5, right? And then it's 10 to the 10 to the 10 to the third. Positive? 10 to the third. Very good. How about this guy? 5.3 times 10 to the -5. How about this guy? 8 times 10 to the -7. Okay, not too bad. All right, how about this guy? 7.84 times 10 to the 7. This would be 8.24 times 10 to the 8, yeah. And then this would be, are you sure? Between 1 and 8, a little tricky, huh? Gave you some extra zeros. So it's 5.2 times 10 just to the -3. So if you went all the way over here, all right. All right, orders of operation. So recall, please excuse my dear Aunt Sally. So no parentheses on A, no exponents. So we'll just go straight to multiplication and division from left to right. So the first one we're going to do is this multiplication, 0.5 times 3. So that becomes 1.5. Everything else, I just do one step at a time and I just rewrite everything. So again, next thing we do is multiplication division. So in this case, it's this division here. And that becomes 10. And I just rewrite everything. If you skip steps, sometimes you might miss something. Now we are in addition and subtraction. And you just do it from left to right. So left to right, 1.5 plus 10. And then you come to 11.5 minus 10. Get 1.5. Yeah. So please excuse my dear Aunt Sally. So first thing we have to do, parentheses and exponents. So we got a parenthesis. We'll do that one first. So that becomes 203. No more parentheses, no more exponents. Now we do multiplication and division from left to right. So the first one is 0.5 times 203. That becomes 101.5. Rewrite everything. We still have a division, so we're still here. We'll do that division next. So that becomes 5.075, and then our last step, now we're in addition and subtraction. What do we do first here? Yep. So this is like orders of operation within orders of operation, right? So there's levels to it. So we have to do parentheses and exponents first. So everything within this parenthesis we should do first. And we'll follow still the same orders of operation. So we are in the first level. So we'll do the division first. Very good. That becomes 10. And then let's go ahead and simplify what's in the parentheses. And that becomes 13. So now we have no more parentheses. We're just back to the second level, multiplication and division. Minus 10. Addition and subtraction are the last steps. Negative 3.5. All right, for this guy, same thing. We got parentheses. Please excuse my dear Aunt Sally. So we'll do the division and multiplication within the parentheses first. And then that simplifies to 10. And then we're left with just addition and subtraction within the parentheses.
It won't ever mess you up in that parentheses on that one if you just put 3 plus 200 divided by 200 minus 10. You still get the same answer, right? It won't ever mess up, or
it can.
It can?
Yeah.
So we should definitely just do that.
Yeah, always do it one step at a time if you're not sure of your orders of operation, right?
Cause I've always put in just the way it is, and just from weird questions.
Yeah, you can't just punch it in.
So I could get wrong.
Yeah. Yeah, sometimes you have to push equal in between things. You gotta do this division first though. It just works out. For this one, it just worked out. Alright, so now within the parentheses, we can do addition and subtraction left to right. So we got the 3 plus 10, and then the 13 minus 10. And then our parentheses are gone. So now we go back. No more parentheses, no more exponents. We're back to multiplication and division left to right. All right. Adding exponents. So adding things in scientific notation, you got to line up the decimal point. So convert everything back to decimals, line up the decimal point, and add. So here we're doing the opposite. 5 means we go 5 to that side, and then 2 means we go 2 to that side. So then we just add. Line up our decimal and add. So here's our decimal. Bam, that's it. Subtracting numbers in scientific notation. Same thing as addition. You got to convert back to decimal form. So now with our negative exponents, you're going to move the decimal to the opposite side. So that becomes 0.068, and then the second term becomes 0.0047. So line up that decimal point and then do your subtraction. So that's just going opposite, going backwards. Multiplying in scientific notation. So when you multiply, you can add exponents. So here we got -1. You're going to add that to this 5. So your overall exponent is 4. Right? So you can do 9.3 times 3.2 times 10 to the 4th. So this, I converted everything back to decimal form and multiply. So if you want to do it this way, you can. So this is option 1. This is option 2. Whichever is more comfortable for you. But if you get tremendously large exponents, like you do for 1 mole, right, you may want to use scientific notation. All right, so that's your second option. There. Same answer either way. Dividing exponents. So you subtract them. 7 minus -3. So what's 7 minus -3?
4.
7 minus -3. Punch it in. If you're not sure, punch it in. So make sure, just punch it in, guys. So, 2 ways. You can use the exponents, or you can convert back to decimal. So here is converting back to decimal. Here is using your exponents. So yeah, very good, 10. 7 minus -3 is 10. Either way, you get the same answer. Whichever way you want to do it. All right, fraction decimal percentages. 3 ways of expressing the same value. And then if you want to throw in ratios, you can as well. So, numerator divided by denominator. Make sure you enter your numbers in medical notation. So 0 in front of the decimal. Times 100 to go to percentage, because cent means 100. 1 divided by 18, you get 0.0555 times 100, 5.55%. 34 divided by 23. So improper fraction, you'll get a number larger than 1, but don't be scared. Same exact method. And then multiply by 100 to get your percentage. If you're starting with a decimal, right, look at the last digit, the last decimal place. So the 2's in the hundreds, just put those numbers on top. 52 over 100, and you can check your work. Here we got the 6, it's in the, whatever that is, millionth. So your new denominator will be million. Just put those, all those digits on top. And you can always check your work by dividing. You guys get scared now. We got a number larger than 1. But do the same exact thing. The 8 is in which decimal place? Thousandths. So your denominator will be 1,000. Right? Just put all those digits on top, and you can double check your work. Of course, multiply by 100 to go to percentage. Now let's start with percentage. A lot of times I'll ask for the fraction because I know you guys will skip this step. So be careful, don't skip this step. This should be one of the easier problems on the final. So first you have to do is divide by 100. Get your decimal, find the decimal place, and then make your fraction. Tens, hundreds, thousandths, 294 over 1,000. So here again, remember to divide by 100 first. Don't skip this step. This is the 10 millionths position. So 517 over 10 million. Same thing here. Make sure you divide by 100 first to get to your decimal. Then once you're at your decimal, you can convert to a fraction. The 8 is in the thousandths. There you go, thousandths at the bottom. Conversion, 50-50. How do you convert? That's it. Your job is to figure out when to multiply, when to divide. Meters and inches, do you multiply or divide? Uh-oh. Uh-oh. Dun, 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 dun. Dun, dun, dun. Inches. Meters to inches. This is our conversion factor right here. Do you multiply by that or you divide by that? Well, let's set it up. All right. Bam. You want your units to cancel out? So we're going to multiply or divide? Multiply. Multiply for this one. Big ol' X there. All right, B. Inches to meters. Are we going to multiply or divide? Wait a minute. I just went from meters to inches. Now I'm going from inches to meters. So, all right, let's set it up. Bam. All right. I want inches on the bottom. So my units cancel out. So the numbers in the denominator, I need to divide. Right? That's it. Either multiply or divide. Your job is to figure out when do I multiply, when I divide. And if you're not sure, go back to the lecture where I teach you guys how to use the power of 1. Right? The power of 1. Remember 12 over 1 dozen? What does that equal? 12 over 1 dozen is 1. There you go. She said 12. No, remember we got to put units to numbers. They mean something else. So you missed that lecture. All these units change the meaning of the numbers. All right, let's do some more conversions. Meters into feet. Do I multiply or divide? Multiply, she says. So our conversion factor is this guy. So let's set it up. Very good. It's in the numerator. You're gonna multiply. Very good. D. Am I gonna multiply or divide? Divide. All right. You already got the pattern from the first one. All right. So set it up. We want feet at the bottom, so it cancels out the units, the number, so we divide. That's it. Conversion is 50-50. Your job is to figure out when to multiply, when to divide. Because I give you, or you guys should bring your conversion factors with you. All right, inches into centimeters. Multiply or divide? 2.54. 1 inch equals 2.4 centimeters. So let's set it up. All right. So it's in the numerator, so you multiply. You guys aren't setting it up. All right. Kilos into pounds. 2.2. Multiply or divide? It's in the numerator, you multiply. So if you're still stuck on this, it's 50-50. Better than Vegas odds. Way better. I'll take 50-50 any day. Football, you have to parlay it though with the under-over. All right, pounds into kilos. Multiply or divide? Uh-oh. Divide. Grams into ounces. Multiply or divide? Divide. So if you're not sure, set it up. So this one's divide. This one's divide. And all you need to do is multiply or divide by the conversion factor. That's the power of them. So if you use them properly, no sweat. IE ratio. So this is for this part of the ratio, and the E is for this part of the ratio. So it's actually 2 and 1. So I is also equal to TI over TI. And E, the ratio for E, is TE expiration over TI. Right? So that's the same thing. So sometimes we'll just use this portion of it. Sometimes we'll just use this portion. Depend on what's given. So here we got TI and TE. So let's just plug in this guy, solve for this guy, because we know this ratio is always going to be 1, right? So there you go. Plug it in. Really, you don't have to do this one. That's extra work. Just do the second one, and you're good to go. 1 to 2. For B, same thing. You just have to do this second one. Save you some time. So you don't have to take more than allotted. So this would be 1 to 3. Easy enough, right? IE ratio. Given the same information, so let's just go ahead and do that. Bam. Just worry about this portion, because you know this is always going to be 1. Save you some time. 1 to 3. Uh-oh. Now everything gets complex, right? So we don't want any fractions in our ratio. So this gives us 1 to a half, 0.5. I don't want any decimals. So let's multiply by 2 on each side to get whole numbers. Right? If I multiply this side by 2 and this side by 2, I'm going to end up with 2 to 1. So this is more of an EI ratio. This time you're given the ratio, right? And you have to solve for either TI or TE. So remember, this number corresponds with that value, and this number corresponds with that value. So plug and chug. So what is TE for letter E? Did you plug it in? So we got 1 to 4. So our number's 4 here. Our TI, sorry, is 1 second. So what is TE? What does TE have to be to equal 4? Right? So 4 divided by 1 is equal to 4. So 4 seconds, right? And then 1 to 3 ratio, TI is given. So let's plug that in. We got 3. That's equal to TE over 0.5. Solve for TE. What does TE equal? So you got to multiply both sides by 0.5. You got to multiply both sides by 0.5. What do you get? 1.5. Very good. Bam. Very nice. All right, so let's do G. So this time we need to find TE. So plug in everything that is given in that equation. This time we got 2 for the E number, 1.5 divided by T1. So how do you solve for inspiration time? Multiply both sides by Ti, then divide both sides by 2, right? So you gotta multiply both sides by Ti and then divide both sides by 2. What cancels out?
2.
So this 2 cancels out on this side, and then the Ti cancels out on this side. Right? So this cancels out here and here. This cancels out here and here. And you're left with Ti on this side, which is that, and then 1.5 over 2, which is this side. Bam. All right, solve it again now, this time for H. Same exact strategy. 4 equals 3.2 over Ti. Solve for inspiration time. 0.8? Oh, nice and easy now, right? 0.8. So multiply by Ti on each side, divide by 4. And then you get 0.8. I think she got it.
I just divide, if it's a ratio like that, I just divide the 3.2 by the 4 instead of going through all this stuff.
I'm going through the steps so people know what the steps are. So you're good. You already got the shortcut. You know what to look for. Just look for that ratio. So you're good. But if you're not sure when to multiply or when to divide, set it up. Same with this. If you don't know when to multiply, when to divide, set it up.
And then one question will say, what is the ratio? And the other one will say, how many seconds?
Yeah. So just be careful. Know what you're solving for. All right, desired oxygen. So 35 or greater, we got to use 20. Less than 35, we'll use 21. So 26 is less than 35, so we'll use the 21 number. So 100 minus 26. Oh, did I mess up? Over 26 minus, this is supposed to be 21. Right? Yeah. So 74 divided by 5 is 14.8. So this should be 14.8 to 1. Be careful with your colon and decimal. Some of you guys are mixing up where your colon and your decimal goes, so just be careful. All right, 31, we are still under 35, so we got to use 21. Okay, so this time I did it right. So I got 100 minus 31 over 31 minus 21 gives you 69 over 10, which is 6.9 to 1. So you're going to turn on your air oxygen. All right, this time we are greater than 35, so we'll use the 20 value. So we got 100 minus 38 over 38 minus 20, which simplifies to 3.4. At 50%, we're still using the 20% oxygen. So 50 over 30 gives you about 1.7 to 1. So 1 decimal place is good enough for the air oxygen ratio. All right, dead space volume. So a couple ways to calculate dead space volume. You can do it by partial CO2. Here we are doing it by partial CO2. So you have to solve for your dead space. And to solve for dead space, here's the equation. Dead space equals your partial CO2 and then your effective CO2 pretty much. So first you got to find your dead space volume and then just divide it by the tidal volume. So here you got to find it, 40 minus 15, and then just divide it by the tidal volume. So 25 over 40, and to get percentage, multiply by 100. So solve for dead space first. So just subtract, find the difference. So here we got 43 minus 25, so that gives us 18 millimeters of dead space. And then just divide that by the tidal volume, and then multiply by 100 to get to percentage. About 41.9% dead space. Yeah, these guys are mostly dead. All right, the second way to find dead space is to estimate based on body weight. And for every 1 pound of body weight, we're going to estimate to have 1 cc, which is 1 ml. Right? So 1 cc equals 1 ml. So for a 175-pound person, we're going to estimate to have 175 mLs of dead space, not exchanging oxygen. And then the tidal volume 600. Take the quotient, multiply by 100 to get your percentage. So about 29.2%. What if the weight's given in kilos?
You have to multiply by 4 plus 7.
2.2. Yeah, so you multiply or divide by the conversion factor. So if you're still not sure, you're going to have to do a lot of converting in between problems. So multiply by 2.2, we get 198 pounds, which is equivalent to 198 mLs of dead space. Divide that by the tidal volume, 550, times 100 to get your percentage, 36% dead space volume. Same equation, you're just going to take the quotient and multiply by 100 to get your relative humidity. So depending on the temperature and condition, this is how much 1 meter cube can hold. Right? So you're going to have to be able to convert 1 meter cubed is how many liters? Okay. So if the units are the same, no problem. You can just divide, they'll cancel out. So 20 divided by 44 times 100 gives you your percentage. And then for B, same thing. All you gotta do is take your quotient and times 100.
So that doesn't say to the nearest 2 points, so you just leave it like that, or just round it?
Yeah, for these exercises, don't worry about it. You should pay attention to what it says in the directions of the quizzes. And a lot of you guys aren't following it. Right? So
We're
when
just assuming that it doesn't say we're to do that, because we would put, make that a 5.
yeah, so everyone on the final will tell you exactly where to round to. So I reviewed the quiz and midterm. A lot of you guys are still not rounding to the desired decimal place. And you guys are still having a lot of compounding errors, which are rounding as well. So just be careful. Round at the end of your computation or keep every decimal point available to you. But on the final and the midterm and quiz and every other assignment, I go back manually and I look at it and I give you guys the points you guys deserve anyways. All right? So, any more questions on which decimal place to round to? I believe I answered that in week 1, repeated again in week 2, 3, and now week 4. But it's okay. Insanity is the definition, right? All right, we got liters and cubic meters. What's the conversion factor? Look it up real quick. If you have to Google it right now. It's on the board. You don't even have to Google it. I give you all the information you need all the time, right? So, 1 cubic meter, you just have to pay attention, is how many liters? 1,000, there you go. So you got to convert.
Let's multiply 87 by 1,000.
So you got to convert. Multiply or divide?
Divide.
Multiply or divide?
Oh, yeah, that.
Well,
Right.
I like using whole numbers. Makes your life a lot easier. Right? So 14 grams per cubic meter, if you have it per liter. So just multiply by 1,000. Right? If you divide by 1,000, you'd get decimals, and then with decimals we go crazy, right? So easy enough. All you got to do is put content over capacity times 100, and you are done. The other way would have gave you the same answer. I just don't like decimals. I'm prejudiced against them. Because you guys always ask me, how many decimal places I need? All right. Your turn. Capacity content. What is the relative humidity? You got it? All right. So again, conversion. Multiply by your conversion factor or divide by it.
Can you not move on that so I can write down?
Yeah, this is just to
I'm not too fresh, but it's.
this is just to kick back and relax. I don't even want you to take notes because this is going to be up on YouTube. You guys will be able to watch the video. We can go through this stuff a lot quicker. That's why I'm not writing anything as we go. It's already prepped, bam, ready to go for you. Because we got 2 weeks. I'm cramming into hopefully an hour or so. Don't sit in front of a comedy show. All right. Especially if you're like a first date, do not sit in front of a comedy show. I might have to rip you a few. All right. Lung capacity, the best thing for lung capacity is to, yeah. All you gotta do is really draw these 3 boxes here. That's it, these 3 boxes. Because TLC is just one full bar. And that you can just remember. Okay? So just remember those 3 columns, plug and chug. All you gotta do is plug and chug. So we got, bam. Oh, I forgot another 1200 here for the other reserve volume. And then add up your columns. Here we got 1 column worth, RV plus VC, all right? That gives us 6,000. So we know each column is gonna be 6,000. So that's the one I looked at first. And then that gave me this answer. So let's solve another one. Now that we know TLC, let's go ahead and solve this guy, right? So FRC minus IC equals TLC. So I can just solve for FRC. Bam, 2,400. And then the next thing is this right here. I guess I'm looking at IRV. So these 2 columns now have to equal the same. So 3,600 for that column and 3,600 for this column. So if we know TV is 500, then IRV has to be, yeah, 3,100. And lastly, we're going to solve these 2 shorter columns here. Right. We know that that needs to be 2,400. RV is 1,200. So ERV is going to be the other 1,200. Right? And then just double check your columns. Make sure each column equals the 6,000.
I have another quick question. On these, like where the boxes line up, you know, the 3. So do you take the larger number and subtract the smaller to get the other box?
Difference. Just think of difference. If you think difference, it doesn't matter if it's larger or smaller. Just find the difference. Just find the difference. So sometimes you subtract, sometimes you add. Just find the difference. Yeah, pictorially, I have it pictorially here for you. So this is those who are picture, and then I have all the equations here for you based on the pictures. Right? So the equations are straight from the pictures. Right? And what TLC is 6,000. Then RV plus VC equals 6,000. Right? FRC plus IC equals 6,000. RV plus ERV plus TV plus IRV equals 6,000 as well. Right? So just match up your columns. Bam, 6,000, 6,000, 6,000, 6,000. You should be good. All right, let's do another example. Let's fill in what's given for us. So we're given VC, IC, TV, and RV. So there we are. We plugged them in. So let's find our TLC value. So what is this plus this? All right, so that means TLC is 4,500. Bam, write that in. So the next missing one that's easy for me to find is this guy, FRC. So I know FRC plus IC needs to equal 4,500. So just find the difference. What is the difference? The difference is 1,700. All right, let's go down to here since this is next. So now we got to find the half columns. So this bottom column here, both of them match. They need to be 2,800 each. I already got 600 here. How much is the difference for IRV? Yep, 2,200. And then lastly, we need to figure out ERV. $1,700. So we got 500 already. The difference is 1,200. Last step, double check, make sure all your columns add up to 4,500 each. 4,500, 4,500, 4,500, 4,500. Last one. This one's a little bit different. So we're given TLC this time, FRC, TV, and RV. So just plug them in where they belong. So let's solve for VC first in this column. So I know everything needs to be 5,000. I already got 800. What's the difference? 4,200. All right, let's go down this column. Let's find this value. We know the total column needs to be 5,000. We already got 2,000. The difference is 3,000. All right, now let's find these small columns here. This column needs to be 3,000. We already got 400. Difference is 2,600. All right, last column here needs to be 2,000. We already got 800. The difference is 1,200. 5,000 for each of our column. Your last check. All right, let's continue on. The homework is open, so if you want to get started on it, you can. There is none. I took it off. I won't be answering any questions from that though. I'm going to continue on with the review. All right, temperature conversions. So keep all your decimals. And the easy thing about these temperature conversions is most of the time the decimal is going to be the same digit repeating. So it's easy to just get a real accurate number. So it's plug and chug. If you're given Fahrenheit, plug it into the F position. If you're given Celsius, plug it into the C position. And if you're given Kelvin, plug it into the K position. So Fahrenheit to Celsius, plug and chug. So anytime we see an F, we're going to put in 37 right there. And then all it is, please excuse my dear Aunt Sally. So inside the parentheses first, and then we multiply by 5/9. So you're going to get a repeating digit. No, this one you get not a repeating digit. You get a nice round number, 2.8 or so. I think that repeats. And then to get from Celsius to Kelvin, we'll just plug in the 2.8 here and then add in 273 to get to Kelvin. So when we do the gas laws, just remember temperatures need to be in absolute. Negative numbers, just be careful when you're multiplying, adding, and subtracting negative numbers. So plug in negative 55. So you owe me $55, you owe me another $32. Altogether, you owe me 87. So don't find the difference. You got to add them. Right? So it's negative 87 times 5 ninths. So about a negative 48. Then we're going to add 273 to that to get the absolute temperature. You do get some repeating digits. So if you have to use the number for computations, keep all your decimal places until the end. All right, this time Celsius to Fahrenheit. So do the easy one first if you want, from Celsius to Kelvin. So let's plug in 86 anytime you see a C. So 86 equals F minus 32 times 5 ninths. So we'll multiply both sides by 9/5. And then to get F by itself, we added 32 to each side. Kelvin one's easy. Negative 20. So be mindful of your negative numbers. So I plug in negative 20 for C. And then to get F by itself, we'll multiply by 9/5 to both sides. And then add 32 to each side. It's negative 4. To Kelvin, add 273 to your Celsius number. All right. Temperature is not too bad. If in a pinch, just look up the temperature conversions. Body surface area. So there's multiple equations for body surface area. We'll just use this one. And the weight, it's based on body weight in kilos. So 4 times the kilograms plus 7 over the kilograms plus 90. So remember that there are parentheses here. So make sure you do everything in the quotient first, everything in the numerator before you divide. All right, so plug and chug. We'll plug in 40 for kgs, simplify it, and this one will round to the nearest tenths. 1.3. So if a person is 105 kilos, we're going to estimate that to be about 2.2. So it's a simple plug and chug. I don't remember.
I'm thinking like you need the person's height to do that, and you don't.
No, this one, all you need is the body weight. So just look at the variables that are required for the equation. And here it's just kg. All right, if you're given pounds, you just have to convert back to kgs. Multiply or divide? Divide by 2.2. So 190 divided by 2.2. So that's about, or it is, 86.4 kgs. So 86.4 kgs times 4 plus 7 over 86.4 plus 90. So about 2 square meters. All right, pounds. Remember, you gotta be in kilos. They want kilos. So units are important. So 113 pounds, about 51.4 kilos. Then we'll plug that in for our kilogram value. Simplify, and we get about 1.5 meters. So this is important because to find cardiac index, we need body surface area. Cardiac output over body surface area. Pediatric dosing. Fried's rule. So it's for infants less than 1 year. So age in months over 150 times the adult dose. So answer wants to be in milligrams. Adult dose is already there, so we don't have to convert too much. So months is 6. 150 is our constant times the adult dose, 250. So for this 6-month-old, we'll give him about 10 milligrams. a fraction of what an adult would get. For a 9-month-old, 9 over 150. This time the adult dose is 50 milligrams. So again, we don't have to convert here. So about only 3 milligrams of this drug. 5 months. This time, adult doses in grams. Answer needs to be in milligrams. Just be mindful, being in the like units. So let's convert everything to milligrams. All right. So 1 gram is 1,000 milligrams. We'll use this number. Half a gram is 500. We'll use that number. So plug and chug. For C, 5 over 150 times 1,000. For D, 10 over 150 times 500 milligrams. And then our answer will be in milligrams. 33 for C. Ooh, also 33 for D. Clark's rule, very similar to Fried's rule, but this is for children. Children for us, about 1 to 12 years. If they hit puberty or they have larger body size, then you can treat them as an adult. Similar, just pounds this time over 150 times the adult dose. So 75 over 150 times the adult dose, 125, and 54 pounds over 150 times 375. So 63 for A, and for B, about 117. Clark's rule. This time, the units aren't the same. So this one, make sure you guys are able to convert into like units. What would you change the 2 grams into? How about the 0.75? Yeah, very good. So we'll use those numbers so our units cancel out. And we got to be in pounds. So here we got 55 pounds and about 88 pounds. So we'll use these numbers because our equation wants pounds. All right. 55 over 150 times 2,000 and 88 pounds over 150 times 750. 733 for C and D, you should get 440. Last of the pediatric dosaging. This time it's going to be a lot different. So we're doing children again, ages 1 through 12 years. So the closest age they are. So for a 7-year-old child, just remember you got to do whatever's in the denominator first before you divide. So 7 over 7 plus 12 times 375. Make sure you add that denominator first. 7 over 19 times 375. If you punch it all at once, it's going to be funny. It's going to give you funny answers. So this kid's going to get about 138 milligrams. 6-year-old, so we got 6 over 6 plus 12. The adult dose this time is 25 milligrams. So remember, you got to do everything in that first. So about 8. All right, so what's today's date? I don't know what today's date is. No, today's date is 11/17. So these numbers work. So I did this a few months ago. So we'll use these ages because it's been about 6-7 months since I did this lecture. All right, so about 4 years old. So we'll do 4 over 4 plus 12 times the adult dose. So we got 4 over 4 plus 12 times 3,000. And for D, about 7 years old. So we got 7 over 7 plus 12. So if you got where the age are, this is today's date, assuming today's date. So for C, this kid would get about 750, and for D, a 7-year-old would get about 92 milligrams. predicted oxygen saturation based on age. So position, supine, you are on your spine, right? You're on your back. And then seated or semi-Fowler. All you got to remember is which equation to plug into. So be careful, sometimes these are inverted for you. Just make sure you're paying attention. So plug and chug, 103 minus 0.42 times the age. And then for seated, 104 minus 0.27 times the age. So supine, about 75 milligrams of mercury. And then in the seated position, a lot better, right? About 86 millimeters of mercury. 27-year-old. So let's plug and chug for the 27-year-old. So supine, make sure you use the correct equation. About 92. So a lot healthier than the 68-year-old. And then seated, a little bit better, 96. So not so much of a difference since they're way up there in saturation. Map. Systolic versus diastole. So the time spent in systole is usually half the amount of time spent in diastole. So in contraction versus relax. Hence, we're going to multiply the diastolic pressure because we spend twice as much time in diastole as opposed to systole. So you get the systolic pressure, you add twice the diastolic pressure, and you divide by 3. And that'll give you the mean arterial pressure. This is the pressure your arteries feel all the time. So plug and chug, make sure that that's your S value, that's your D value. About 93 average for A. For hypertensive, 140 over 90, your artery is going to feel this much pressure all the time. So about 15, 16, 14 millimeters of pressure all the time more. That's 15% more damage on the body. All right, let's plug in 110 and 70. So 110 plus 140 over 3, about 83. So this is ideal, I guess. 120 over 70. That should be our goal. Now you're given MAP values. You have to find either diastolic pressure or systolic pressure. So plug and chug and just find the missing variable. So for A, we're given MAP. We're given diastolic. All we got to solve for is systolic. So plug and chug and solve for systolic pressure. So here's systolic pressure with this funny S so it doesn't look like a 5. So I plugged in everything. Now all I got to do is solve for systolic pressure. So multiply both sides by 3. And then you're going to subtract 2 times 108.
What's that first? You get 126 equals what? Is that a 5?
That's an S. Yeah, it's a funny looking S so you don't mistaken it for a 5. So that's systolic. That's this value here. So plug in everything and then solve for your missing value, S, systolic. So multiply both sides by 3, because you got 3 in the denominator here. So multiply both sides by 3. And then we get 378 equals S plus 216. So to get S by itself, we subtract 216, our algebraic computation. And then we find S is 162. Same thing. We are given MAP. This time we are given diastolic pressure. Let's look for systolic. So same thing. This funny looking S here is to let you know that it's an S and not a 5. So we plugged in our MAP value. We plugged in our diastolic value. Now we just solve for S. So multiply both sides by 3. So when we do that, we get 318 equals the systolic pressure, funny looking S here, plus 146. So to get S by itself, we subtract 164 from both sides. And then the systolic pressure, this funny looking S here, so you don't mistaken it as a 5, is 154. Plug and chug to solve for the missing variable. In this case, your systolic pressure. Let's look for diastolic pressure. So we have to contend with this 2 value here. So again, plug and chug, find what is missing. So it's 2D. So that's a D, not a 0. Let's write it in red. So this funny looking 0 round thing is actually D for diastolic. So to get D by itself, multiply both sides by 3. And then we're going to subtract both sides. So let's make this a positive D. So we'll add 2D to both sides. So D equals about 102. All right, D. Same thing. We're looking for diastolic pressure. Don't get tripped up by that too. So plug and chug. Plug it in. This is a funny looking D right here. It's not a 0, not an O. It's your diastolic variable. So we multiply by 3 on both sides. What do you guys get for D? Multiply by 3 on both sides.
Which is 396, subtract the 142, 254.
Then divide by 2.
Divide by 2.
Yeah, that's the last step. That's that 2 right here. Told you. Don't forget that 2. There you go. Very good. So that last step, that 2 comes into play this time. ET tubes, they come the nearest half size. So if you're directly in the middle, so if you're at 0.25 or 0.75, you can go either way, up or down. Right? So they only come half sizes. You can do it by age, or you can do it by height. And the units you need are years and centimeters. So plug and chug for A. So 13 plus 16 over 4. So remember, you got to do everything in your numerator first. So 29 divided by 4. And this one, since it's right dab in the middle, either or. $611. So 6 months ago, this kid was 6 years old. So 6 plus 16, so 22 over 4, exactly 5.5. No rounding needed for that one. All right, ET tube now based on height. So we got feet and inches, 3 feet. Oh, where's C? There it is. Let's do C. So C is 1.08 meters. So we got to convert that to centimeters. So centi means 1/100. So just multiply by 100 to get 108 centimeters. And then plug it in. 108 centimeters divided by 20, 5.4. So we'll round up to the nearest half millimeter, 5.5. All right, lastly, for height, ET tube, endotracheal tube, 3 feet, 5 inches. How many inches is that? 41, right? So take 3 times 12 plus 5. So 12 inches per foot plus 5, that's the remainder. So yeah, 41. So 41 inches. You got to convert to centimeters by multiplying by 2.54. So now the height is in the units we want, centimeters. So 104 divided by 20, so about 5. We got to round down to 5. So conversions will be built in to some of your problems. A, you don't have to do any conversions. B, no conversions. C, D, you're getting to multiple conversions. All right, last topic, cardiac output and cardiac index. So when you say output, that is over 1 minute. A stroke, that's just 1 beat. So we take the amount of volume per beat times the number of beats per minute, and that'll give you the flow. How much per minute? And it's usually in liters. So remember, 1 liter is 1,000 mLs. So let's find CO. Just multiply 75 times 70, divide by 1,000, and then you'll get your liters. For the next one, 60 times 82 mLs, and then just divide by 1,000 to get to liters, 4.92. So that is how much blood your heart is pumping per minute. Cardiac index, we just take that amount of blood per minute and we divide it by surface area, right? And we call that cardiac index. So if you have CO, you need to be in liters per minute, and your body surface area needs to be in meters squared. So your final units, liters per minute, meters squared. Plug and chug, just CO divided by body surface area. So for the first one, about 3.6 liters per minute per meter squared. For the second one, we're not given body surface area, but you know how to solve for body surface area. So this is a 2-for-1. So 4 times the body weight plus 7 divided by the body weight over 90, right? 4 times the body weight plus 7 divided by the body weight plus 90. So they have about 1.86 square meter body surface area. CO is already in the units we want, so we just divide by the body surface area. 4.5 liters divided by 1.86 meters squared. So an index of about 2.4. All right, let's put it all together. We got stroke volume, we got heart rate, but we need to find CO, right? Easy enough, but remember, it has to be in liters. So if you multiply those two numbers, you get mLs, but we want liters. So now that we have CO, all we got to do is divide by BSA. It's given to us this time, 1.7, easy enough. 4.68 is our output, 1.7 is our surface area, index of about 2.8. Very common mistake, not being in liters. All right, so this is going to make you do everything. So you have to find CO, which is easy. Just remember it needs to be in liters. This you got to convert to kgs, and then from kgs you got to find BSA, right? So no sweat. So here we got the CO, cardiac output, 5.12 liters per minute. Pounds to kilos, easy enough, 79 kilos. 79 kilos to body surface area, right? Plug in 79 in the equation, about 1.92. Now that you got surface area, you got cardiac output, you can find cardiac index. So all the little steps, you apply them, And then this is type of the question that you may never seen before, but you have all the foundations, all the building blocks to get the answer. So we're testing higher cognitive skills. All right, so that ends. Get your assignment for today. Get it in by class time tomorrow. We'll go over it real quickly, and then we have part 2 tomorrow.